So I'll hand it over to Charlotte. Give her a big hand.
Thank you, and thanks to Brian and Yoshi for inviting me. I can already tell this is going to be a very interesting day. So, hello, my name's Charlotte. I'm going to be talking about the conflicting, sometimes harmonious, relationship between computational and physical craft. I'm going to do that through the lens of my project Hexatope. But firstly, my whole life story. It's the morning. I think you can handle it. So I don't remember a time before being interested and curious about how websites work. I started making websites when I was 11. They were awful, really bad. But by the time I was 16, I had a little business making Tumblr themes, and it was still pretty bad. But by the time I got to decide what to do for university, both of my parents thought I should do maths or computer science or something like that. But I always felt stifled by the lack of creativity and specifically the lack of tactility in that, and thought I could always come back to computers. So I decided instead to go to art school. Firstly, to study fashion, that was the idea, but I just tried to keep an open mind, and what ended up sticking was jewellery design. So I really love learning about materials and how they can be manipulated. And there's like such an enormous history of craft, like millennia of wisdom to learn from. But the thing that I found most thrilling was being able to make beautiful objects with my hands that had an intrinsic material value. But after 5 years of working with jewellery, I'd kind of fallen out of love with it. It's really hard to make the perfect piece of jewellery. You have to have a lot of patience and a lot of attention to detail, neither of which I have in abundance. Because if you mess up or you change your mind about something, it can be days of work lost. But meanwhile, I was still working on the web, and I got on kind of okay by then, hopefully. I mean, I was employable. And I was spoiled by the instant feedback you get when making websites and the iterative nature of the process, how you're always building on what you've been doing before. And also, craft is a linear process, and the architecture and like higher level of order that you get working with tech was really fulfilling for me from a mathematical and engineering standpoint. So I've always had this conflict of being more of an artist and also this kind of algorithmic programming side of me. And I never thought they could be combined. So I decided to stick with the web, mostly because I made more money. But around this time, I started finding loads of really interesting generative artists on the internet, people doing incredible stuff with JavaScript and open frameworks, people like Anders Hoff and Matt Delorier and Zach Lieberman. I mean, such incredible work. And I thought maybe I could do this kind of thing. Like, it probably wouldn't be the same like tactile way I was used to working creatively, but it would be so exciting to have the tools of technology and computers, the iterative nature, how fast they are for creative processes. After all, art and design, from sculpture all the way to illustration, is all about development. It's all about building on what you've done before, trying new things, and moving forward the best one and repeating the process, which aligns really well with the digital workflow. So I went back to university to study computational arts at Goldsmiths as a master's. This is the first program I wrote on that course. Completely unrelated. It's just nice visual distraction for you. So this course was aimed at either artists that wanted to learn how to code or coders that wanted to be more artistic. But the majority of people there were people that had very little or no experience in programming, but with a strong artistic practice that they thought could benefit from coding. But one of the first courses we had was on processing, and for myself and a couple other people in the class that did have some experience programming, it was so slow. It took us like 4 weeks to get to loops. So we actually made an offshoot of the class. They gave us a PhD candidate to teach us some things, and he was really interested in modeling biological phenomena and programming emergent behavior. So he taught us about generative algorithms and flocking and that sort of stuff. So at the end of our first term, he was just like, go and make something. It really had no limitations besides that it needed to be on screen, but could be in any language. And I decided I wanted to combine 3 things. The first thing was Conway's Game of Life. I did it, woo. So this is a simulation of evolution. It's a grid of cells, and they can either be on or off. And every generation, the cells turn on or off based on the amount of active cells around it, so they can die from overpopulation or starvation, and they can also be activated from having the right amount of stuff around them. It's quite a simple kind of thing, but it reaches an equilibrium and is also just like very visually satisfying. And I wanted to make it with hexagons. No particular reason, I just think hexagons are a really interesting shape, the way they tessellate, the sort of symmetry in them. It's not as perfect as Conway's original Game of Life, because it needs a bit of genesis. I think every 1% of the time things just turn on randomly to keep it in a sort of equilibrium state. But the thing I wanted to combine it with was this thing from the generative design book, or generative Gestaltung. I wrote it out phonetically so I could pronounce that properly. So this is a Cartesian grid for drawing, but the way each kind of cell was drawn, the glyph, depended on the active cells around it. So I thought that would be a cool thing to do with Conway's Game of Life, and even more interesting if I just make it in hexagons, because why not? So I started out quite simply by just connecting the edges of each active hexagon with a curve. And I found that the whole Game of Life thing, it moved quite quickly. So I faded out the background so it would, you could see the evolution a bit more easily. And yeah, I was already this is the very start of this project, but I was so proud of it, because it just seemed to me like one of those cool things you see on the web and that you're like, I'm never going to be able to make something that cool. But it's actually like really not that hard when you get into it. And I was just, at this point, I was like, I need to just keep developing this no matter what. So the next thing I did, instead of adding more visual complexity by changing the glyph, I thought I would just kind of modify it. So for the ones that are more dense, that have more than 4 active neighbors, instead of connecting every active side, I made a few different layouts so that it wouldn't be so dense. And these are randomly chosen when the hexagon is activated. And at this point in time, the Game of Life thing I just feel like wasn't working anymore. So I tried a whole bunch of things, and the thing I ended up sticking with is this creator and destroyer method. So there's one kind of thing that goes around and leaves a trail in its path, and then there's another one that goes around and destroys everything. I'm not sure if you can see the tiny hexagons, but it's up there. And then to make it a bit more visually interesting, I added this double active state. Again, instead of changing the glyphs, I thought, let's just make it so it can be disabled, active, and double active, and then the lines have to kind of emerge and diverge from each other. And then finally, I rounded out all of the things, so, you can't see because there are too many things killing it. There you go. So it's all little circles. And I just want to pause and gush over how awe-inspiring this kind of creative coding can be. I wrote some rules that draw lines between the sides of hexagons. There are 21 different layouts here. And if you take into account the rotation and the emerging, diverging lines and all that, that comes to about 1,400 different variations. And yeah, I wrote some rules of how they could fit together as well. But it creates these incredible structures that I just couldn't even dream of, to be honest. And making a physical object takes a lot of practice. But with minimal digital tools, especially web interfaces, you can make something interactive and cool really quite simply. Tim Holman, who is another web developer, who's been on a similar path to me the past couple of years, getting into this generative art thing, he made this website called Generative Artistry that goes through a few different pretty simple generative art things, and it has a cool little thing that draws as you go. And I think this is just, yeah, and then you can end up with some Joy Division cover art. So if you're interested in getting into generative art, this is a really great resource for it, because it's very instantly gratifying, this kind of thing. It's amazing how much, just with a couple loops and variables, you can create something that's really special. Yeah, I think this form of art is enabled by 2 qualities of that only digital materials have compared to physical materials. And the first thing is duplication. If I wanted to make 2 rings, say the second one's slightly different. I'd have to make the same ring twice and then, add a bit to it. But if you want to make two different versions of the same program, you only have to make the program once, and then you can copy it and, change a bit of the original thing. It's like an additive medium. So this means that when you want to learn something new, you get to start from the farthest you've ever got before, without having to repeat all the previous steps as you would when you're making something. The other quality is reliable consistency. We try really hard to get physical materials to behave this way, and they do. It's mostly that we're not very consistent about how we affect them. But with programming, if you give it the same input every time, you'll get the exact same result. Consistency isn't always desirable. If we think about like biology, we wouldn't be able to survive without mutation. So computers being able to make the same thing every time over and over again isn't really very useful. But with generative art, the way we take advantage of the repeatable aspect of it is that we vary the input. So this uses simulated randomness to change things. And I made a few little keyboard things on here just so I could play more with it and see. So is it going to work? Yeah, so I can wipe the board and make like a load of creators and see what happens. Or similarly, I could wipe the board, make one creator and loads of destroyers and see how far it gets. But then I also added a mouse. So instead of just the random behavior of these creators and destroyers, we can use user input. And this is the part where I start getting distracted by drawing things on screen. I was sort of playing around with this when I first made it. And I got to a certain point. It was probably after making, honestly, it would have been hundreds. But now I look at it, I'm like, very instantly. I realized I was just making jewelry. Since then, I've realized that everybody has a different opinion of this program. I remember talking to a biologist about it once, and I was explaining it, he didn't really understand it, so I got up my phone and showed him this demo, and he was like, oh my gosh, this is like a perfect visualization of these protein string thing I was working on. And I was like, it's just hexagons, mate. But like, I saw jewelry in it, so that's what it was to me. But it could be anything. So I realized I had to keep working on this. This was finished as a university project at this stage in January, almost 2 years ago. And for the masters, from May to August, you work on one final project. And most people start something new from as an accumulation of things they've learned in the year. But I decided to come back to this and see how far I could push it. At this point, I was a bit sad because I'll just get some and then you'll find out why I'm sad. I was sad because at this point, it's like a perfect binary thing. And I knew I was going to turn it into something messy and physical, because that always happens when you try and do anything physical. But I was more excited about the idea of being able to touch the outcome. So then the big question was, how do I transform this into jewelry? What does it mean? Is this like a personal design tool for me that I can make a collection on here and get it produced in China and make millions of pounds? Or is it like a user-based thing? The pipe dream was, wouldn't it be cool if other people could use this program and then I could somehow make them into a reality? The more I play with it, the more creative it made me feel, just by discovering new patterns. Because obviously you've got like the layouts, but it's more how they work together. You get these like symmetrical patterns. They're like these Celtic mesh wire designs. And I realized it could be a tool to make anyone feel creative, because it has a really low barrier to entry. It's pretty beautiful. Even if you just like open this and just randomly scroll along the page, like you'll make something quite nice. And you can have finesse inside of it, but you get the immediate feedback, which reinforces that feeling of creativity. So I started trying to figure out how I can make this a smooth user experience. I've now got this too much. Can I wipe it? Yeah. The first thing to do was to rewrite the whole thing. So this was originally written in P5.js, which is a JavaScript implementation of the processing library, which is an added layer on the JavaScript Canvas API. I don't know why I started with that, so I just rewrote it from scratch in plain JavaScript. And there were a couple of refactoring things. Like originally it was quadratic Beziers. You may be able to tell from that it's not quite smooth. And I need to make them to cubic Beziers, so they will all be perpendicular to the edges of the hexagons. And at this point, I really wanted to not think about how I was going to materialize it at all. Like, I didn't want to be weighed down by the practicalities of production. I just wanted to make a perfect visualization inside the screen of what I would want physically, and then I'll deal with the rest of that later, because otherwise I feel like it would be really confining. So since that epiphany of this is jewelry, I couldn't stop seeing this as wire, as like wire form jewelry, which I'd done quite a lot of work in. And I was thinking about how I bring this into a third dimension, and thought a lot about having sort of like a grid of like 3D hexagons. That'd be really messy. And I realized the most pure thing is that there are kind of crossing and overlapping lines in this system. And what would be great is if they could do that on the Z index. Z index? This isn't CSS. So this was a really intimidating stage of the process, because I knew what I want, but I just didn't have any idea how I was going to get there programmatically. Like, so much of this project was, oh, I know what I want to do, but how do I write code that does that? That seems impossible. And I realized that you just do it, and then eventually you figure out how to do it by doing it. So with this, I wanted to break it down. So I started by making these mock-ups on Photoshop of just how I'd like the curves to overlap in an ideal world, in hopes of discovering just a really simple rule set that I could code up in one afternoon. That didn't happen. So deciding how these curves would interact with each other, it was a really intuitive process for me, like by hand in Photoshop. But making a algorithm or a rule set that's flexible enough to work with anything and just copies exactly what my mind would do would be impossible. I thought about machine learning, but I didn't really have time or scope for that here. So I had to accept that whatever algorithm I made wouldn't do really what I wanted it to do. Earlier, I was praising this architecture of technology over the rudimentary linear process of craft. But, you know, I could make that in wire. It would take me like a day or two, but I could do exactly that. But how long would it take me to make an algorithm that just approximates that? It's easy to forget that the tech architecture, the complexity is sometimes a burden, because it has to be able to take any input and turn it into a desired output, which is much harder than bending some wire with pliers. At scale, algorithms are obviously more efficient than a human intervention. But I realized that this has already got a lot of human input in it. It's already someone drawing on a screen. Why not make it so that they can also control how it works in a 3D space? I thought a lot about it, and I realized it boiled down to a user experience decision, and ended up deciding to make an algorithm that controls it, because at heart, this is supposed to be a really simple tool that creates complex outputs. And between those two things, there's like a lot of space where me/the computer has to make decisions for you. This is a conflict I have all the time when I'm adding and changing features of this program. I could certainly do a whole different talk about it, which is like, do you give the users more control, which results in a wide range of outputs, but you also have the risk of choice overload, or do you kind of confine the options for simplicity, for aesthetic cohesion, or and that just limits the output? Anyway, back to the algorithm. So I want to break down this problem on a hexagon by hexagon basis. So if we zoom in on this one, this isn't the beautiful flowing Celtic wire that it seems. Every single curve is just goes between the edges, the middle of the edges of each hexagon. So if you think about them as individual curves, it makes this problem a little bit easier. And I wanted to add a Z value to the just control points of each of those curves. So if we look at this, there are five overlaps, and they all actually are on the same layout of hexagon. They all have like a low X going across them. It's like a slightly easier view of them with the purple is the one that I want to be on top. And if you can like rotate your brain, there's the left-hand 3 are all going the same way. It's always the left of the, sorry, wrong way around for you, the left of the X, and the right 2 are the other way around. And that's a problem, because I can't just randomly choose this. And I didn't want to write anything that would figure out the symmetry of the object or whatever. So I just decided to flip the other 2. So then on a layout by layout basis, I could always say, this line should always go above this line. And then I expanded that to other layouts. There's like an M layout here. Again, I can see this so clearly because I've been working with this for like 2 years, but I'm aware that no one else can probably. So I thought, why don't I bring up the edges of those things? And then why don't I like bring down the X there and then bring up, and then you end up with this whole mess that definitely doesn't make sense to you. It barely makes sense to me. But once you average out all of those control points and then smooth out the whole curve so it kind of undulates in the third dimension instead of just being like randomly jerky, I ended up with this thing. So at this point, I made the demo white because it didn't need to be a hacker interface anymore. And I wanted to keep the left as this kind of canvas and the right as a sort of visualization space. So I added a couple more layouts here that you can kind of like hover over and click on, etc. But yeah, then we get this. Ooh. Yeah, that's not the most attractive one I could have made. I was like, I'm under lots of pressure to make a good design on the left-hand side. We'll just make it slightly, yeah, that's what I want. Do that random sticky out bit. I want to leave some control of depth over to the users. So we have 2 sliders here. I'm going to try and, so if I bring them both down to 0, it's perfectly flat. And this first one controls the thing that I was talking about before with like certain layouts, like that one there, end up going over. And this second thing, if you can see, it brings up the kind of middle inside curve of anything that's doubled up. So between these 2 sliders, you get like some control over how you'd want this design to look as a 3D object. Oh. So I achieved my goal. I made this like visualization of exactly what I wanted in reality in the browser. So this was all, the visualization side was all happening with 3JS. Got this really sexy, shiny material going on with it. And now it's time to start thinking about how I make this into something physical. I thought what I would have to do is export all of that data and in some weird file format, and then like crack it open in a 3D modeling software like Rhino, and then make a script that creates all these pipes and all that. Turns out there's an add-on for 3JS which allows you to export objects in 3JS as STL files. So STL files store 3D objects as triangulated surfaces, and you can use that inside 3D printing software. So basically, I could 3D print it by just clicking a button in the browser to, you can make something in the browser and then download a 3D file from it, which is just insane, so cool. So at this point, 3D printers. There are 2 main factors I had to think about here. The first is quality. Most desktop 3D printers are extrusion-based, so they just kind of like poop out some melted plastic a lot, and they're not particularly fine quality. And the other thing I want to think about is the material I want it to end up in. And for me, that's always metal. I'm just a metal fiend, mostly silver. So the way that most silver jewellery is made with 3D printers is that you 3D print the thing, and then you make a rubber mold. I'm going to go into this more in a little bit, but I'll zoom through it. You make a rubber mold of the thing, and then you cut that thing out, and then you make a wax copy of whatever your 3D print is, and then you can use the normal lost wax casting method to make that thing. But because all of these designs are going to be so undulating and thin and delicate, I wouldn't be able to do that anyway. I wouldn't be able to make the mold and cut it out and do that. So those were issues. This is the dream. This isn't what I ended up doing. But there's this technology called direct metal laser sintering. And is this YouTube video going to load? We'll see. There's one machine, maybe more than one machine in the world. I've seen one of the machines in the world that does this directly in gold, which is fascinating. So it costs a fortune. So this takes powdered metal and just like melts it with a laser and brings it down and adds another layer of the powder, which is just the ideal production method, but is obviously extremely expensive. And it does not happen in these 4 steps. It's like 5 micrometers or something like that. So I didn't have this. But what we did have at university were a couple of these Formlabs Form 2 machines, and this is what I ended up using. So it works similarly to the DMLS thing, but sort of the other way around. So it's a liquid resin machine that uses a laser to cure it from underneath. So the board kind of goes up. And extra advantage is that they make a few different materials that you can use in this machine, and one of them is a wax prototype material. So that instead of doing the whole make a mold and then make a wax copy in the middle, you can cast directly from the outputs of this machine. So yeah, this was my first output. I actually brought it here because I'm so proud of it. I have like quite a few things over here. So in the break, you can come up and have a look, and I can talk to you about it. Yeah, the little like roller coaster tycoon structure behind it is the support structure that's made when you print it, because it needs something to like hold it to the baseboard. I also completely lied about the chronology of events here. Like, I did this long before I did. As soon as I realized that you could export 3D objects from 3JS, I was like, I'm printing that. It was before I did any of the overlap stuff. But this was a bit too big. The second batch was a bit too fine, a bit too fragile. They kept breaking. And then, like, the Goldilocks of 3D printing, the third one was just right. This ended up being about 1 mil thick wire, if I made it out of wire in the first place, which is actually the thickness that most wire work is made out of. So, perfect. So now I'm going to go through the rest of how you make this into a metal thing by talking over this snazzy video. So, yeah, first starts with the 3D printing. The next step is that because it's this special like wax material, it has to be cured in a UV chamber to harden it before I take it to my casting place. Yeah, the next is removing all the structures, that and the step before. It doesn't matter what order you do in that. But yeah, at the casting place, my good friend George, he uses like these little wax sticks to make these things called sprues, which allow the metal to run through and get to the end of the objects. Because they're so fine and fragile, the metal would cool too fast before it got to the end, so it needs to have these sort of channels to run through for the cast to work successfully. So they end up looking sort of like that. I've really streamlined this process now. I 3D print those. Yeah. And then he puts them on this wax tree, and then it goes into a flask, and that flask is filled with plaster, really like fine industrial grade plaster. Before it gets put in a kiln and heated up loads, and then that burns out all of the wax inside. So you're left with a negative of the wax in the perfect shape you want in the plaster. And then the metal, in this case silver, is melted, and with a vacuum that gets forced into that negative space. So you end up with this like amazing tree of silver, which is just, it's so cool to see and like feel these. They're really heavy. So then he cuts off these things off the main tree. I take them back to my workshop and cut off all the sprues, do a lot of like filing and sanding and polishing. And then to make them into actual pieces of jewellery, I didn't really want to manipulate them further because I think the natural forms of the shape are really beautiful. So I decided at the beginning to just keep them as pendants. So this is me adding it to a chain. Perfect. Yeah, and then you end up with this incredible, shiny piece of metal jewelry. Like, I've achieved my goal. I have a production chain. Woo! Yeah, so this was where I presented it at the end of my master's. At this point, I had to come up with a name for this project. And we all know naming things is like the hardest job in web development. You know. I was kind of at a loss to name it. So I had an old jewelry brand called Hexatope, A pentatope is the simplest four-dimensional object, so it's just 5 points all attached together. I think it's just like so simple and mathematical. It really worked with the work I was doing then. And for this, I was like, I mean, I guess I already have a name for a jewelry brand, but that's 5, so I'm just going to like up it to Hexatope, and then that ended up being the name of the company. So yeah, I made a jewelry cabinet, which I don't advise anyone to do here, and showed this work alongside of the program. And again, at this point, I was like, it's coming to the end of the project. I need to keep going somehow. So I was leaving university, so I was leaving access to these wonderful 3D printers, and I couldn't give up on it. So I decided to launch a Kickstarter so I could afford to buy this 3D printer and be able to, build out this integrated online shop that I'd envisioned. The biggest time for jewelry is around Christmas. So I finished this master's in September. This was 2 years ago. No, a year ago. And I was like, okay, within like 3 weeks I need to launch Kickstarter so that in a month it can end, so that I have enough time to get people's responses and I have enough time to make the things all before Christmas. And I actually, just before this talk, got an email from Kickstarter being like, hey, it was a year since it's your anniversary of your fully funded project, so that happened a year ago today. Yeah, so that was the 16th of November. And so then I had a whole load of things I had to make. The main reward in this Kickstarter was you can design your own pendant. And I had a lot of apprehension for the sort of things people would end up making. There was a size limit inside of the program, but honestly it was really generous. It was like this big when it was in, yeah. So a bit scared that I'd get some really awful things. There are a couple of awful things in there. Don't look too closely. But I was actually really surprised at the quality of some of them. Oh yeah, these were the 3 solid gold pieces I made. Thank God that they weren't too big, otherwise they would have just cost me more than it would have taken to, But yeah, I was actually really amazed by the designs. Those 2 ones on the left are just incredible, and I could see people using the program and see them spending days perfecting their design. And by this time, I knew this program back to back. I knew everything you could make with it, was what I thought. Well, I did technically, but I just wasn't using it in the same way as these other people were. So they made things that were just unlike any of the things that I was making, which was really fascinating. Oh yeah, also there was I love that in this photo you can see that my thumb is bandaged by masking tape. There was also this surprising kinship between some of the pieces. These 2, just completely separate orders. I'd never made any of these shapes before, and they just had that relationship to each other, which was really interesting. There was a whole language that all of these pieces were talking in. That it was amazing to see people get creative with it. Yeah, in this talk, I feel I've presented this project. The development of this project is pretty natural, pretty easy, but there have been a lot of rabbit holes and a lot of roadblocks along the way. For example, on the digital side, I had this photo shoot last June, I think, maybe July, for earrings, and I still haven't launched earrings on the site because of just a dumb code problem. And I have a similarly long-standing frustration with the physical side of things. The quality of castings is a bit inconsistent because of that prototype wax material, but I'm going to solve that soon by printing in-house. So we get to my final comparison between making things digitally and physically. And I find that the problems with making anything digitally inevitably have to do with increasing complexity while maintaining order, which is pretty good for a perfectionist like me, because if I'm making a website, given that I've been making good decisions along the way, the outcome is always going to be as good as it can be at that stage. But physical materials invite their own complexity, whether it's from the properties of the material or the production process. The struggle is usually in simplifying and refining it. If I could print directly in precious metal without having to saw off sprues or like sand down these marks from support structures, I would never stop smiling. It's a fight from the start to mold the material into what you want it to be. The room for improvement is painfully visible, and as eternally frustrating as that can be, and while I'd rather take a digital bug over a physical bug any day of the week, there is nothing like the feeling of making something and holding it in your hands and being proud of it. I am so happy that more digital processes are melding into physical ones and that the web is becoming more creative and more like material. Because I no longer have to compromise between being a developer and an artist and a maker. I can take the most engaging aspects of each of these disciplines and put them together in a single project. Thank you. You can check out Hexatope. The deadline for Christmas orders for Hexatope is December 2nd, so, check it out.
Thank you very much.